So today I was checking my email and I got a wonderful message from a student by the name of Zeddy. Zeddy wanted to know if there was a way that you could solve a system of equations using matrices. I thought, you know what? That sounds like a really good idea. Let's go ahead and show you how to do that for today. Now, this is quite a process to do, but you can break it down into the following steps. First, we're going to take our system, convert it into a matrix. Then we're going to use row operations to solve that matrix. And then once we're done, we'll have a new matrix and we'll go ahead and interpret what the solution means. Now be careful, you may remember that when solving systems, these may have no solution or infinite solutions, so you definitely want to be on the watch for that when going through the solving process. Now, it's a little bit different when using matrices. When you're doing that solving process, there's only three things you can do. Number one, you can swap two rows of that matrix, and you'll see me often use the notation, something like row 1 is swapped with row 2, and I'm just replacing them. Secondly, you can take a row and you can multiply it by some non-zero number. So in this case, I've taken row 2, I've multiplied it by the number 4. And again, you'll see me use this notation where I'm just saying what number I'm multiplying the row by. And lastly, and this is a really big one, you can add a multiple of another row and then replace a certain row. So in this particular setup that I have here, I'm taking row 1, multiplying it by 3, I'm adding it to row 2, and then with that result, I'm going to make it my new row 2. So you're seeing this notation kind of explain that process. 3 times row 1 plus row 2 becomes the new row 2. Now the reason why we're doing all of these operations is we're hoping to get our matrix into a diagonal form. This is also known as the Gauss Jordan elimination method. So we'll have some sort of generic matrix to begin with, but in our first step, we're really worried about getting a 1 in that first row and our first column. Once we have a 1 there, then we'll go ahead and use that combine and replace operation to get a 0 with everything else in the first column. So we'll just have a 1 and a whole bunch of zeros. It'll look really nice. As we continue on, we'll now get a 1 in the second row and the second column. Once we have that 1, we'll use that replacing operation to get zeros everywhere else in the second column. And as our matrix gets bigger, we'll keep going down the diagonal, getting 1s along the diagonal. So the next time, if I had to put another 1 here, we'd get a 1 in the third row and the third column, and get zeros everywhere else in the third column. All right, try not to get too intimidated by these steps. Let's go ahead and just jump into it and see how this works. All right, so step number 1, we want to convert this into a matrix. And really, that's one of the nicest steps in all of this process. You really just want to look at the coefficients of all of your variables, and they become entries in your matrix. So for this first little row of my matrix, I'll have a 3 and a 2. These will represent the coefficients on x. For the next column here, I'll have a 2 and a negative 5. And then my last little row here, I'll have a negative 9 and a negative 6. So notice how you're only keeping track of the coefficients. You're not too worried about the variables. But in the back of your mind, you're remembering that these really are coefficients on x. The second column are coefficients on y, and these are just our constant coefficients. All right, so done. We've converted it into a matrix. All right, now it's time to bust out our row operations and see what we can do with this. We want to get it into diagonal form, so we're going to get a 1 right in this first row and first column. So how can I get a 1 there? Well, one of the best ways I can do it is I can take my first row and I can multiply it by a 1/3. So let's go ahead and look at that notation. I have 1/3 times row 1. All right, so we just want to go down this entire first row, multiply everything by a 1/3. So 3 times 1/3 is a 1, 2 times 1/3 is a 2/3, and negative 9 times a 1/3, that'd be a negative 3. So there's our new row 1. We haven't done anything with row 2, so we'll leave that exactly the same. We're not going to change that just yet. We'll save that for another step. You don't want to do too much while you're working through these operations. Okay, so that looks pretty good. We've taken 1/3 of row 1. We have a new matrix. Now we want to continue on. Since we have a 1 here, now we want to get zeros everywhere else. To get those zeros, we're going to use a process of combining and replacing. So I'm going to take my second row, row 2, and we're going to subtract twice my row 1, and that'll become my new row 2. Now, this is going to be a lot of work, and I don't necessarily want to gum up what I'm already doing with my matrices, so let's run over here and do a little bit of scratch work so you can see exactly how this is going to play out and why I'm using this subtracting of 2 row 1, why I'm really doing that, all right? So what I'm saying here is take row 2 just as it is. 2, negative 5, negative 6. There's my row 2. And I want to essentially take row 1 and multiply it by a negative 2. So let's take all these entries, multiply by negative 2. So 1 times negative 2, negative 2. 2/3 times a negative 2, that's a negative 4/3. And negative 2 times a negative 3, there's a positive 6. So I'm really just going to add these together and see what I get. So let's see, negative 5. That's a negative 19/3. Negative 6 plus 6, 0. There we go. So these, this little scratch work tells me how these will combine, and this result gives me the new row 2. So I can just go ahead and write that in as my row 2. 0, negative 19, 3, and 0. That looks pretty good. We haven't done anything to the first row, so we'll just go ahead and copy that down. And this thing is getting a little bit closer to actually being solved. It's looking better and better. We can see we have a 1 in the first row, first column, zeros everywhere else. Our next goal is to get a 0 down here. Let's go ahead and get some space. Now give that a try. All right, so to get a 0 in, or to get a 1 in this next spot here, we will take our second row. Let's multiply it by the reciprocal. So we'll multiply it by 3/19. And we want it to be a positive, so we'll multiply by a negative 3/19. Of course, we want to do that to everything in the second row. So 0 times that is 0. This negative 3/19 times negative 19/3, there's a 1. And that times a 0 is a 0. So looks like the second row is very nice now. We haven't done anything to the first row, so we'll just go ahead and copy that down. Leave it right like that. All right, so that's looking good. Now it's time to get zeros everywhere else in this second column. So we'll use that combine and replace. Let's see, what shall we combine? Well, we'll take row 1, we'll subtract 2/3 of row 2, and we'll make this the new row 1. Okay, that looks pretty good. Again, let's get some scratch work just to make sure we don't gum up what we're doing with our matrices. So here's our row 1. Okay, that looks pretty good. We want negative 2/3 times our second row. So negative 2/3 times 0 is 0. Negative 2/3 times 1 is negative 2/3. And negative 2/3 times 0 is 0. All right, let's add this up. 1, 0, and negative 3. So this becomes our new row 1. All right, so let's write the result. 1, 0, negative 3. We haven't done anything to the second row, so we'll go ahead and write that as it is. And there we go. This is now in a diagonal form because we have 1s right along this diagonal here. That's really what we're aiming for. Over here, we'll have usually a column that could be numbers or anything else, but that's the form we're aiming for. It's time to interpret our solution. Here, remember, these represent coefficients on x. So this essentially just says x is equal to a negative 3. And these are my y's, so y is equal to, looking at that number there, 0. So I have a solution that x is equal to negative 3 and y is equal to 0. You can also write this one as an ordered pair if you want, but either way, you have a solution. Now, you can even do this process for much larger matrices. Be forewarned that the process just gets a little bit more involved when you're doing that combining and replacing process. So let's go ahead and give this particular system a try and see how it works for a much larger system. All right, same step as last time. We just want to convert this into a matrix. So we're going to take all of our coefficients like the 4, 1, negative 1. Then I have a 2, negative 4, and 0. Let's see, then a negative 3, 1, and 2. And my constant coefficients are 6, negative 4, and 2. Okay, so that's not so bad. We have a matrix. Now we actually have something that we can work with. Now we're going to work on getting a 1 in our first row, first column. Hey, but look, there's a 1 sitting there in the second row. I can actually just swap 2 rows to get it there. So let's do that. We'll say, let's take row 1, and we'll go ahead and swap it around with row 2. That's the only change we'll make, is just swapping these 2 around. So let's see, I'll give us a 1, a negative 4, a 1, a negative 4. And this will be our new row 2. So 4, 2, negative 3, and 6. And we haven't done anything with the last row, so we'll just leave that as it is. Negative 1, 0, 2, and 2. All right, now that we have a 1 in the first row, first column, it's time to zero out everything else. Let's see, how can we do that? Well, I can take my row 2, we'll subtract 4 times row 1, and then we'll make that the new row 2. Notice how I'm trying to do a lot of manipulations on row 2 because that's where I want the 0. We also want a 0 here, so we'll do the much the same idea with row 3. We'll take row 3. If I add just row 1 to it, then that can become my new row 3. So these are the operations I want to do. Time to do some scratch work so we don't mess up too much stuff. So here's row 2, 4, 2, negative 3, and 6. And we want negative 4 times row 1. So I want to take row 1, multiply it by negative 4. Then I can go ahead and add these together. Let's see, 22, and this will become my new row 2. All right, let's do the same thing here. So row 3, that looks pretty good. Row 1, add those together, 0, negative 4, 3, and negative 2. And so there's my new row 3, and now we can write down our new rows in our matrix and see exactly what we got. So this replaces row 2, so 0, 18, negative 7, and 22. And this replaces row 3. We haven't done anything to row 1, so we'll leave that just as it is. And our matrix is getting a little bit closer to that diagonal form. Looks like we need some more room, so let's go ahead and grab another whiteboard and continue on with this process. All right, so now we need a 1 in the second row, second column. Well, I think you're probably getting good at how this works. We'll multiply everything in that second row by a 1/18. The fractions are going to get a little ugly at this point. You just got to kind of hang in there and march on through, not worrying about too many of those fractions. It'll be okay. So let's see, a 0, 1/18 of 1, or 1/18 of an 18 is 1. Then we have negative 7/18. And then we have 22/18. Maybe not the nicest of fractions, but oh well. What you gonna do, right? 0, negative 4, 3, and negative 2. All right, there's our matrix. Now we have to get zeros everywhere else in the column. That means above the 1 and below the 1. Let's see how we're gonna get those zeros in there. So I can take my first row here. Maybe I'll add 4 times row 2. That seems like a good idea. And that'll become my new row 1. We can also look at row 3. Yep, row 3. And essentially do the same thing. We'll add 4 times my row 2. That'll become my new row 3. All right, let's go ahead and grab some scratch work, see exactly what this is going to look like. So let's see, I need row 1. So there's 1, negative 4, 1, negative 4, and 4 times a row 2. So there's 0, 4. Oh, got to do a little bit of work with those fractions. Let's see, that's negative 28/18 and 88/18 when you multiply a 4 times a 22. All right, time to add these up. 1 plus 0 is 1. Those add and give us a 0. That's really what we're aiming for here. Let's see, to add these two, I can imagine that as 18/18. There's negative 10/18 for the result on that one. To combine these together, let's see, that'd be like subtracting a 72. So that's 16/18. Whew, oh boy. So those represent our new terms for row 1. Now let's do the process for row 3. So row 3, 0, negative 4, 3, negative 2. I'll multiply the second row by 4. We've already done this once before, so I'll just copy this, what I have written before. So let's see, and now I have an 88/18. And now I just have to add these up. Okay, so 0, 0, 3 plus negative 28/18. That's 26/18. Negative 2 plus 88/18. That's a toughie, but that is 52/18. All right, now we have some new rows. Now we can actually write down our matrix and see what this thing turns into. So the new row 1, 0, 1, 0, -10, 18ths, 16/18. Row 2, well, we haven't changed row 2, so I guess I'll just write that down exactly as it is. -7/18 and 22/18. And my new row 3, here it is on the bottom, 0, 0, 26/18 and 52/18. Lots of fractions starting to stack up near the end here, but look, we're getting that diagonal. It's getting better. All right, now we need a 1 in the third row, third column, so I need to multiply by something right there to do it. We're going to multiply by its reciprocal, 18/26, and we'll do that for row 3. Now we're only doing this on row 3. Everything else is going to stay exactly the same. So let's just quickly copy those down since, they're not changing. Let's see, 0, 1, -7/18, 22/18. And here's the important one, the one we're actually changing. 0, 0, let's see, since we're multiplying by their reciprocal, that becomes a 1. 18/26 multiplied by 52/18. Well, the 18ths cancel out, so I'll have 52/26, and that reduces to just 2. All right, so it is getting a little bit nicer. Now I have 1s along the diagonal. Time to get some 0s above that 1. Right, again, more space, but we're almost home free. So how can we get the 0s above the 1? Well, we need to do that process of replacing, and then I think we'll be okay. So let's see, to get a 0, we'll take our row 1. We'll need to add 10/18 of row 3. And then this will become our new row 1. Let's see, we need to do something similar for row 2. So row 2 plus 7/18 of row 3. And that becomes a new row 2. On to our scratch work so we can keep everything nice and clean. So row 1. (16/18). All right, okay, so there's all of our row 1. 10/18 times row 3. Good thing the numbers are fairly nice in this one. So 0, 0, 10/18. And then let's see, multiplied by 2, that'd be a 20/18. Time to add it up. 1, 0. These are the same but negative, so 0. These will combine to give us a 36/18. And of course that reduces to 2, but we'll wait until we actually write down the matrix. Let's see, these other steps. So I need row 2, just as it is. So let's see, 0, 1, -7/18, 22/18. And then we'll take 7/18 times row 3. 0, 0, 7/18. 7/18 times 2 is 14/18. All right, and now we add these up. 0, 1, 0. These will combine to give us a 36/18. So what do you know? Another number of 2. All right, so let's write down this matrix. See exactly what we get. So these were to give us a new row 1. So 1, 0, 0. This reduces to 2. All of this work was to give us a new row 2. So 0, 1, 0, and that reduces to 2. And the last row, we haven't done anything to that, so we'll leave it exactly the same. So now we have our matrix in the diagonal form, 1s along the diagonal, and now we can just interpret our solution. So it looks like x is equal to 2, y is equal to 2, and finally z is equal to 2. So as an ordered pair, this is just 2, 2, 2, and we have our solution to a system of 3 equations and 3 unknowns. Thanks again, ZD, for sending this one in. If you'd like to see some more of my videos, please visit MySecretMathTutor.com.